Okay, number 39 in your classwork for quadratic equations asks you a park question. So we have the following claim. If the point 2 plus d, comma y is on the graph of the function f of x is x plus 2 times x minus 6, then the point 2 minus dy is also on the graph. So use algebra to show that this claim is true. What is the relationship between the line x equals 2 and the graph of f of x? So we can solve, if they want us to use algebra to show that this claim is true, then we would need to say that plugging in 2 plus d gives us some f of x value that is equal to the f of x value when we plug in 2 minus d. So, right, f of 2 plus d, we want to prove that this equals f of 2 minus d. So, we can go ahead and for every x that we see here, we can plug in a 2 plus d. So we'd have 2 plus d plus 2 times 2 plus d minus 6 is equal to 2 minus d plus 2 times 2 minus d minus 6. So simplifying inside this parentheses, we have d plus 4 times d minus 4 is equal to negative d times negative d minus 4. My bad. We have 2 and a plus 2 here, so we have a 4. So multiplying this out, we'd have d squared, then plus 4d, then we have minus 4d, so it would be a net 0d, and then we have minus 16, because it's like the product of a sum and a difference, is equal to this, let's just brute force it, so we have 4 times negative d minus 4 minus d negative d minus 4. We'll have negative 4d minus 16 plus d squared plus 4d. This minus 4d and this 4d cancel out. So we come up to d squared minus 16 is equal to d squared minus 16. And so this is true. So that's the end of our algebraic proof. And so what does this mean? So if I wanted to find the x the x value for the vertex, right? My x value for the vertex would be negative b over 2a, or it's the average of the two x-intercepts. So my x-intercepts occur when f of x is 0, so x plus 2 times x minus 6 equals 0, so I can have x plus 2 equals 0, and x minus 6 equals 0, so my intercepts are at negative 2 and 6, and so the average of these two, right, would give me negative 2 plus 6 over 2, which is a 2. So my vertex occurs on the line x equals 2. So this means that my function is completely symmetric around the line x equals 2. And so this is why when we plug in a value that is offset by the same d in each direction, we get the same resulting y value. So if we try to draw this out, right, I'm not going to sketch the exact function, but it's the generalization when we have a vertex here, or really, right, my intercepts are at 6, so it's somewhere off here and here. Then my vertex would occur somewhere down here. So if we have a graph like this, right, then if it's perfectly symmetric around this x equals 2 line, if we offset by the same d value in each direction, right, 2 plus d and 2 minus d, then these points should be, or should have the same y value.